Okay, welcome back, geometry. We are on section 3.3, which is slopes of lines. Now, a lot of you guys that had algebra last year, you guys will know that we dealt a lot with slope last year. So some of this is review, but we use it in geometry as well. So we've got to make sure that we basically know the basics of slope before we go on to how we're going to apply it in geometry. Remember, slope is the ratio of the change in y over the change in x. Okay, the change in y over the change in x. And we also refer to it as rise over run. Rise over run. Rise is your y value, run is your x value. And then it's kind of trying to write it as a unit rate, if at all possible. All right. And then the formula, of course, remember, is m is your slope equals y2 minus y1 over x2 minus x1. So you take those coordinate points and subtract them. We should know how to do that from last year. So let's take a look at some examples here. Let's look at number 1. All right, so we look at our 2 points here. First, let's do it just by going rise over run and just counting it. Okay, so if I say rise over run, rise is our value up and down. And so if I just go from this point here, if I just count 1, 2, 3, 4, I rose a value of 4. So that's my rise. And then running is left and right. So if I go from this point here to 1, 2, 3, 4, 5, 6 to that point there, then that's my rise over run, which is 4 over 6, which we can reduce. Let's try to do that. So m would be equal to 2/3 in that problem. All right, let's go over to number 2. And this one, let's actually use the coordinate points. Okay, so on this one, we're going to say this first point up here, we're going to use as our x1, y1. But let's get our coordinates. So we're going to go 2 on x, and then 1, 2, 3, 4, 5. So this point here would be 2, 5. And the other point, second point, let's say this would be 1, 2, 3, 0. Right? 3 on x, it doesn't go anywhere up or down, so 3, 0. And now we can use our slope formula, y2 minus y1 over x2 minus x1. Okay? So if I do that, and we'll say I just kind of put that work right here, m equals y2 minus y1 over x2 minus x1. So if I label these points, if this is my first point, and I say this is x1, then this would be my y1, and then over here would be x2, y2. You don't have to do that, but if it helps you to put the points in the right direction, then you might as well. So in this case, if I do that with the formula, my y2 is 0, my y1 is 5, so it'd be 0 minus 5. With my x's, x2 is 3, x1 is 2, so it'd be 3 minus 2. That way, when I equal it out here, it would be 0 minus 5 is negative 5, and 3 minus 2 is 1, so it'd be negative 5 over 1 would be my slope. Or we could, since it's a unit rate, we could just write it as negative 5. Okay? So a couple good examples there. Number 3 and number 4, you can just kind of take a look at. We'll kind of need the next page for that, but number 3 and number 4, we'll talk about those on the next page as well. But they have interesting situations here. Number 3, we have a vertical line, and number 4, we have a horizontal line. So what would the slope of those be? So we'll kind of talk about that on our next page here. So if we have a positive slope, what the line is going to look like, it's kind of going to go from left to right in an upward direction, because a positive slope is going to have a rise and a run heading in the positive direction. Remember, your rise, positive, would be up, and your run, your positive, would be to the right. So kind of up and to the right would be a positive slope. Where negative would be just the opposite. A negative slope is going to look kind of like this, because you'd have at least one of that would be negative. Either you'd be going to the left, or you'd be going down with your rise over run. So one of those values has to be negative. So your negative slope is going to look like that. Zero slope. So a slope of 0, let's take a look at what would it be if we would kind of use rise over run as an example. So if we use rise over run here, if it's a 0 slope, then it's going to have no rise at all, right? Because 0 over whatever it would be. Let's say it's 0 over 1. Doesn't matter what the bottom is. If the top of that fraction is 0, that means our slope's going to be 0, okay? For example, if you just had like y equals 0x plus b in your slope-intercept form, well, that 0 is going to mean it's not going to go anywhere rise or run. So it would be a 0 in your rise, which would mean it's just going to be a horizontal line. So that's like kind of like number 3 on that example from the page before, would just be a horizontal slope. And again, you could kind of look at it and say, well, if y equals 0x plus b, 0 times anything is 0, so it would really just be y equals b here. So a lot of times your equations are going to be y equals a number, and that would be a horizontal line slope. And just the same for an undefined, in this case, your run is going to be equal to 0. Because remember, anything with a 0 in the denominator, I'll just put 2 there, could be anything. Anything with a 0 in the denominator is undefined because you can't divide by 2. So an undefined slope is going to have a run of 0, which means you're not going anywhere left or right, you're going just straight up and down. So it'll be a straight vertical line. I'll do a better one of those. Okay, and those are going to be in the kind of phrase x equals a. That's going to kind of be the term they're going to be using there. So if you have a y equals b line, a y equals something, y equals a number, then we know it's going to be a horizontal line with 0 slope. And if it's a vertical line, then it's going to be in the form of x equals a number, or x equals a, x equals 6, x equals 4, something like that. So 0 slope is horizontal line, undefined is a vertical line. And then you can see your positive negatives here. Okay. Here's a word problem that involves slope. We can kind of work on this in class the next day. You just kind of have to put the numbers in the right spots for your y's and x's, and then it's just finding the slope again. All right, so now let's try to tie this into the geometry portion. So slopes of parallel lines. So one thing we have to remember is that parallel lines have the same slope. Okay, so because they're never going to cross, they're going to go up and over, or they're going to rise and run at the same rate. So they're going to have the same slope if they're parallel lines. Okay, and then all vertical lines would be parallel because they're all running straight up and down, so they would all be parallel. An example would be in this diagram over here, line L and line M. Line L is parallel to line M. I gotta do one more M there. Yeah, because they have the same slope. You can see the slope is 4 here, slope is 4 here. So because they have the same slope, we know that they're parallel. And then we can talk about perpendicular lines. Perpendicular lines have a negative reciprocal slope, negative reciprocal. So when we take a look at those phrases, negative and reciprocal, first, negative is basically going to mean opposite. Another way of saying negative reciprocal would be opposite reciprocal. So if one's positive, the other one is negative. And then we should know also what a reciprocal is. Remember, that's like your fraction would be, flipping to be the opposite. Okay? So an example here, and we can say that vertical and horizontal lines are perpendicular. One is straight vertical, so straight up and down. One is straight horizontal. We know that those are perpendicular. So one example here would be, say, line P and line M. So line P would be perpendicular to line M. And why? Let's take a look. Here's line P, and it has a slope of negative 1/4. And line M over here has a slope of 4. So if you take a look at those, negative 1/4 and 4, those slopes are opposite reciprocals. They opposite because one is negative, one is positive. They have opposite signs. And then one is the reciprocal of the other. 1/4, the reciprocal of 1/4 is 4. The reciprocal of 4 is 1/4. So opposite with the signs and reciprocal. All right, so now let's do a couple of examples here. First, determine whether AB and CD are parallel, perpendicular, or neither. So let's just do the first one here, letter A. Okay? And we should put little line symbols here. These are lines. So AB and CD are parallel, perpendicular, or neither. So again, it could be any of these three. So parallel, we're going to say would have the same slope, basically, same M. Or is it perpendicular? Where perpendicular is going to have, what is it, the opposite reciprocal, right? Or neither is basically going to be neither of those cases. It's not the same, and it's not an opposite reciprocal. So that's how you're going to have to kind of figure that out. So let's look at, we've got what, A, B, and CD. Okay, so A, B, we're going to kind of look at these two here, and then we're going to separate those and do two separate slope problems, because here's CD. All right, so with A, I'm going to kind of go with slope, and I'm just going to put the AB down here to say, okay, line AB, that's what I'm finding the slope of. And here I'm going to go y minus y and x minus x. So if this is my x1, y1, this is my x2, y2. So I would go 7 minus a negative 5 for my y's, and my x's would be 4 minus a negative 2. Now, of course, remember we got a chum here because we got two negatives. So now that's really going to be 7 plus 5, which is 12, and 4 plus 2, which is 6. And 12 over 6 can reduce, so I know that the slope of AB is equal to 2. Okay, 2 over 1 or 2, right? And now we're going to do the same problem for, let's put a little line here, for CD. So if I go a slope of CD, I'm going to say, again, I could put these x1, y1s if I need to, and x2, y2, if it helps you. But the slope of CD then is going to be negative 2 minus 2 for my y's, and for my x's it's going to be 8 minus 0. All right, so negative 2 minus 2 is going to give me a negative 4, and 8 minus 0, we know that's 8. So my slope of CD, if I reduce that, can be negative 1/2. So if we compare these two slopes, we've got a 2 here, and we've got a negative 1/2 here. Are they the same slope? No, so we know they're not parallel. Are they opposite reciprocals? Yes, they are opposite reciprocals because 1 is 2, the reciprocal of 2 is 1/2, and they're opposite signs. 1 is positive, 1 is negative. So I would say these two are perpendicular. And I could just use this sign here as well. Okay? So that's an example there. All right, let's check this one out. We've got, let's scrap number 7 for right now. And then let's just go ahead with number 8 here. Graph the line that contains the point 0, 1 and is perpendicular to QR with those coordinates. Q has those coordinates and R has the other ones. Okay, so the first thing I'm going to do here is I'm going to say that if I look at Q and R, that's what the points I know is negative 6 and negative 2. So if I put that point on there, let's go with point Q at negative 6, 1, 2, 3, 4, 5, 6 on X and negative 2. That would be point Q right there. And point R is at 0, negative 6. So I don't have to go anywhere left and right, I just go down 6. And that's point R. Okay, so that's one line if I just connect those. All right. So one thing I'm going to do here is, because I want to find that it's perpendicular, I'm going to have to find the slope of QR to begin with. So if I just go ahead and say slope of QR is, then I can use these 2 points, these 2 coordinates, and say, well, -6 minus a -2 over 0 minus a -6, that should give me my slope. Choom here, and it's going to become a -4. And then choom here, it's going to become a +6. So -4 over 6, or it's going to be -2/3. Okay, so now here's the tricky part. Because I know that it has to be perpendicular, okay, then I know that the slope of the new line has to be the opposite reciprocal. So my slope of my new line that I'm putting in there has to be the opposite reciprocal of this one. So the opposite will make it positive, and the reciprocal is going to make it 3/2. So I know my new line has got to be have a slope of 3/2. I also know that it includes the point 0, 1. So if I put 0, 1 here as point P, then I know I can use this slope. And when I graph this, I'm just going to use the rise over run and say, well, it's going to go up 3/2. 1, 2, 3, 1, 2, 3/2. 1, 2, 3/2. Okay? So I've got 2 points this way. But I can also go the other way, right? I can go down 3/2. 1, 2, 3/2. And you can kind of see how it's going to be perpendicular to that line as well. Okay? So that would be the graph of that one. You can see how it's perpendicular. Okay, so let's save the other problems that we didn't do or questions for the next day, and bring your questions in, and we'll go over this stuff at that point. Okay? Thanks a bunch. We'll see you next time.